Greetings, everyone. This is Matt Fiello, a technical marketing engineer with the Cisco Compute BU, and I'm back with another Intersight Managed Mode Expert Series video. This time we're going to talk about the port policy, probably the most important policy in our domain policies, which then get consumed by the domain profile. Reason for being, well, this configures all your ports on your FI. Okay, so it's a very important policy, and we're going to talk about some principles and recommendations in a few slides, and then go on to a demo, probably be just a little bit longer demo, because this policy has a lot of things to configure. So with that, let's discuss about the port policy. Okay, so with the port policy, we said that it was probably the most important policy in the domain policies. Well, it's going to basically configure all your unified ports, which is what ports are Ethernet versus fiber channel on your given fabric interconnect model, because they can be different. You get the option of configuring breakout ports and also port roles, all important, for the individual ports or the port channels. That as well is the purpose of the policy. If you'll recall, in UCS Manager, you had to make a given server port on a given fabric hot. You had to configure a server port and then enable that port for discovery to take place. All it took was one port on one fabric for the chassis discovery to take place. Well, in Intersight Managed Mode, everything's a policy. Okay, so as we configure this policy and then incorporate that in the domain profile, then deploy that down, then those ports are being configured on the fabric interconnect, and then post-configuration, then the discovery will automatically take place. In addition, this policy allows you to set a discovery order for your chassis. So if you got your chassis stacked 1, 2, 3, 4 in a given rack, top to bottom, and you want them 1, 2, 3, 4, then this policy here will allow you to map the given ports to a given chassis number, and I'll show you that. Now, as far as where this policy is used, it's used by the domain profile. So you build the policy or policies, and I say that because a lot of times this port policy is created fabric specific. So you'll have a port policy name -A for A fabric, port policy name -B for B fabric, and really where that comes into play is if you're using fiber channel uplink and you have virtual SAN numbers, okay, identifiers that are different between fabric A and fabric B, which is common, then you're going to want to create two separate fabric-specific port policies. I also want to point out, and I've pointed out in several of the videos, while you have the option of attaching an Ethernet network group policy in the fabric port policy, okay, for the bulk of UCS users out there, you're not going to want to do that. Just leave that policy blank on the fabric port policy side. Now, you're going to use an Ethernet network group policy on the server profile side, and we'll talk about that in another video. But if you're not doing disjoint layer 2 and you're not uplinking appliance ports, then do not attach an Ethernet network group policy on the fabric side. Reason being is for the bulk of UCS customers out there, they're creating VLANs. Those VLANs get auto-pinned to all the uplink ports and port channels. Okay, so there's no need to try to steer, because the system itself is going to pin those to all the uplink ports, Ethernet uplink ports, Ethernet uplink port channels.
Okay, as far as recommendations go, if you're using fiber channel, then you're going to configure unified ports for fiber channel. Then, try to think ahead, try to plan for extra capacity. We've talked a lot about the the rationale, if you're using fiber channel and you have different vSANs on the different fabrics, the rationale for having two port policies. That certainly holds true. Even if you're not doing fiber channel, you may still wish to consider have two separate port policies. Perhaps you're going to be making some kind of port changes in the future. Breakout configurations, speed changes. Those can be disruptive to the fabric. So at least if you had two separate port policies, then you could introduce the change to one fabric at a time and still be highly available. Then finally, if you're using breakout ports, you need to define them up front. Changing these ports, the configuration, for example, going from a 40 gig port to 4x10 is an example. That's going to be disruptive to the fabric.
All right, as far as verification, once you've created this policy and you've created and deployed a domain profile, you can go into the CLI, connect Secure Shell to the Fabric Interconnect, do a connect NXOS, and then do a show int brief, and then you're going to see all your ports and port statuses and how they're configured. And last slide here before we go on to a demonstration. With all the Intersight Managed Mode Expert Series videos, I'd like to be able to show some context of where this policy is used. So we have domain profile on the left there, and you can see it directly allows the attachment of the port policy as you build the domain profile. So not deeply nested as with some of the other policies. And of course, I show fabric-specific port policies here, again, with the use case of fiber channel. You're uplinking vSANs, and those vSANs are different on A and B fabric, which is common.
Okay, so for the first demo, we're going to create a policy, and we're going to kind of model it for a 6536 Fabric Interconnect with the new 100 gig IFM. But before we actually start building the policy, I want to point out several of the documents that are available out there. This hopefully will be helpful to people new to UCS and to Intersight. We have our 6536 FI spec sheet. This is a wonderful document, so I highly suggest everyone go out there and download that and consume that information. Also, the Fabric Interconnect hardware installation guide certainly is a great resource. Then for X series, the 25 gig IFM module spec sheet and the new 100 gig IFM spec sheet. So these are all wonderful guides. Again, download those, look those over. They're great resources for in preparation and to use as you build your port policy. So let's go back to the spec sheet here for the 6536, and we're going to go to supplemental information material. And this will basically give you a breakdown of the ports and their capabilities. Notice the last 4 ports, that's for unified ports. You can set those for fiber channel at 8, 16, or 32 gig. And as we go down through the document here, it talks about connectivity. We got several use cases here. So let's talk a few moments about those. This first one has the 6536s hooked up to a California chassis with 2408 IOMs, and that's and those are 8 ports of 25 gig per. Okay, so great example of using the breakout cables here because we're consuming 2 of the 100 gig ports and breaking out to 25 gig for the IOM for each of the blocks of 4 ports here. I'd like to also show the 6536 FI connected to a Washington chassis, but with the first gen of the IFM at 8 ports of 25 gig per port. So again, using breakout cables. And then the last example here is the 6536 FIs going to a Washington chassis with the new 100 gig IFM. So 100 gig per port. So it's just a 100 gig port on the IFM connected to a 100 gig port on the 6536. This is the max bandwidth for UCS at this time. We'll use this kind of as our use case going forward. Again, this is kind of the creme de la creme. This is for all the Trekkies out there, Warp 9.99. Let's model this with a port policy. So now we're going to flip over to Intersight. Make sure you're in infrastructure service, policies. We're going to create a policy, and we're going to filter down to our domain policies and select port. Okay, so I like using meaningful naming conventions. So I usually start off with something that delineates my domain that I'm going to assign this port policy to. I'm going to use a numerical value here for the type of FI. My 100 here is for the 100 gig IFM. And then again, what I consider to be a best practice, always build fabric specific port policies. Okay, they will serve you certainly if you are uplinking fiber channel and you have different vSANs on the different fabrics, which is common. And even if you're not uplinking fiber channel, if you think about all the possible parameters in a port policy, you can change breakout port speeds, you can change unified ports, port roles, okay? Any of those types of changes going forward are possibly disruptive to that FI. So you don't want to change one policy that's going to affect both FIs. Have one policy per FI that gets deployed with the domain profile, one for A and one for B. That way, if you're making changes that are disruptive to your A fabric, you're just changing the A policy. Okay, B continues on. And then after you make the changes to A, then you can make the changes to B. So, it would entail two deployments of the domain policy, but it's safer, okay, and it ensures that you can stay operational during these types of changes, okay? So in my case here, I'm going to always put a -A or a -B on the policy name. And don't blow over the switch model here. It's always going to be 6454, but we have a 64108 and now the 6536. And click next. All right. So in the 6536, as mentioned earlier, the unified ports are all the way over here on the right. There's just 4 of these 100 gig ports. And notice that as we start to move the slider, they're actually being configured as fiber channel breakout ports. So this is a first for a UCS fabric interconnect. We can actually configure fiber channel breakout ports. Okay, so we're going to do that and click next. And since we've already designated with unified ports and breakout, we're going to go ahead and finish the configuration for that. So we're going to click on fiber channel and select both those ports and then click configure. So here is where you're going to modify the speed if you need to. So you're going to have to work with your SAN fabric administrator and make sure you're selecting the right speed for these ports. We will keep them at 4x16. So 16 gig of bandwidth per port in these breakout ports. Okay. Now, going over to Ethernet, we can also configure breakout ports as well. And of course, if you were interfacing, as you saw in one of the use cases, with a California-based chassis with maybe a 2408 IOM at 25 gigs per, then you're going to be configuring breakout ports for the servers to go 25 gig. But in our use case, we're going 100 gig to 100 gig, 100 gig port on the IFM to 100 gig port on the 6536. So we're actually not going to configure breakout. Let's click next. Okay, so now with port roles, we have to configure our server ports that will be connected to our IFMs in our chassis. We have to configure our Ethernet uplink ports or port channels, and we have to configure our fiber channel uplink ports or port channels. So in this case, let's go ahead and start with the fiber channel port channels, and we're going to create a port channel and make sure we select FC uplink port channel. Okay, and you can see that we have a port channel ID here, so let's put in a number here. Of course, you're going to get that from your SAN fabric administrator. Let's go ahead and switch that to 16 gig. Okay, and you're going to need your vSAN ID. So here's a classic example why you'd have two different port policies, because your vSAN ID for your FC uplink on the A fabric might be a different vSAN for the B fabric. Okay, or you might have more than one. Okay, so make sure that you adhere to that. And of course, we need to select our ports. I'm going to select all the ports. You can see them here, and I'm going to click Save. All right, so I have my FC uplink port channels. Now I'm going to create my Ethernet uplink port channel, and I'm going to keep the speed at auto. I am not in a disjoint layer 2 architecture use case. I am not uplinking appliance ports. So therefore, I do not select an Ethernet network group policy for my domain port policy, which becomes part of the domain profile. You keep this blank. That's the bulk of users out there in the UCS world. We'll keep that blank on the domain profile. Port policy of the domain profile. So let's go ahead and click our flow control policy. And I'm not going to really cover these because we have separate videos for those. So I'm assuming you've already digested that content. Okay, and we are going to select the uplink ports for the port channel. And of course, you can do it in the graphic. You can select the ports manually by clicking. And we're going to click Save. All right, so we have our Ethernet uplink port channel. So now we have to create our server ports. Okay, and as such, because we have 8 100 gig connections per chassis, that would occupy 8 ports. I'm going to pretend that we have 2 chassis. All right, so I got 1 through 8, but also 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so 2 chassis worth at max bandwidth of 100 gig per IFM to 6536 connection. Click Configure. Server ports. Okay, pay attention to the warning here. If you have a certain Nexus upstream switch that can't do auto negotiation, you have to disable that. Otherwise, keep auto negotiation. Manual chassis server numbering. So that's a good thing. Okay, and you can do the autofill, but I find it just as easy to come in here and just put the numbers. But basically what you're doing is you got to know the mapping, the port mapping, okay, between your chassis IFMs and your FI ports. If you know that, then you can affect how your chassis are discovered as far as what order. So if you've got, for instance, 2 chassis in a rack, in our example here, okay, and chassis 1 is on top of chassis 2, and you want that in order, 1, 2, okay, and they are appropriately cabled from left to right, okay, on the 6536, okay, then you can come in here and simply provide the ordered numbers here. So I got 8 ports going to chassis 1. And then I got 8 ports going to chassis 2. And that's the reason I actually wanted 2 chassis to show you in the use case here, so I can show you the numbering here. Okay, so this is only as good as you understanding the actual cabling, okay, between the chassis and the chassis IFMs and your fabric interconnect. But if you've cabled in somewhat order, top, bottom, left, right, okay, then you can actually affect the order. And that's pretty important to a lot of customers out there, that they discover the chassis in the appropriate order. So click Save. Okay, so we have our chassis server ports delineated. We have our Ethernet uplink port channels configured, and we have our fiber channel uplink port channels configured. Okay, so now we can save the policy. And I like to go back in and view it again. This is a very involved policy, lots of clicking, lots of configuring. It is entirely possible you made a mistake. So come back in here and check the policy, and then go down to the last screen here, and we can see that everything is properly configured. If you expand this out, you're going to see the port channel numbers. If you do the column spacing correctly, you're going to see the speeds. And that concludes our first demo. Okay, moving on to our second demo. This time we're going to create a port policy, but focus on a 6454 fabric interconnect and connecting down to a California-based chassis with 2408 IOMs. As I did in the first video, I'd like to point out a couple documents. So we have the spec sheet for the 6400 series fabric interconnects, and also have its corresponding hardware installation guide. And let's go back to the Intersight now. Infrastructure service, policies, create a new policy. Use our UCS domain policy filter. Select port. I'm going to give it a meaningful name. Okay, so creating a port policy for 6454, 2408 IOM connectivity, and this is going to be for the A fabric. We already have our switch model selected by default, 6454. Okay, so now we're looking for a 6454. The first 16 ports are unified ports, all Ethernet configured by default. So we want to designate some fiber channel ports. We go ahead and move the slider. You want to plan ahead for this, because this is a disruption to the fabric interconnect. If you change this in the future, you can move it to 8 ports if you wish, to plan for some future expansion. Then we're going to click Next. Okay, so this time I'm not going to really configure any breakout options. I'm going to have my Ethernet uplink on my 40/100 gig ports at the end there. And as you noticed with fiber channel breakout ports, that's only applicable to the 6536, as we reviewed in the first demo. So let's go ahead and click Next. Okay, so let's set our Ethernet uplink port channels. Okay, so I'm going to create a port channel Ethernet uplink port channel. Need port channel ID from your network administrator, and we're going to pre-populate in our policies that were covered in previous videos. Once again, no Ethernet network group policy. We're not doing disjoint layer 2. And we're going to select going to select our ports for uplink and click Save. Okay, so those can be 40 or 100 gig uplinks, depending on the optics and connectivity upstream. And let's go ahead and create a fiber channel port channel. I'm going to change the default here to 16. Have to give it a vSAN ID. And we're going to select the first 4 ports. Click Save. Okay, so now we need to do our fabric, our surfer ports. Okay, we see that our first 8 ports via unified ports were designated as fiber channels, so we'll start with port 9. Okay, I'm going to connect 4 of the 8 ports from 2 different chassis. And we're going to configure those as server ports. There's our manual chassis numbering. And the first 4 ports are going to go to chassis 1. And the second 4 ports are going to go to chassis 2. Click Save. And click Save. Okay, so let's go back in and select this and just verify. Okay, we have our fiber channel uplink port channel. We have 2 chassis worth of server ports. Okay, and we have our 40 gig Ethernet uplink ports. Port channel, actually. Okay, so that completes this demonstration. That completes our video about Intersight Managed Mode port policies. I hope you found it informative and was able to learn something. Please consult our other Intersight Managed Mode Expert Series videos. And until next time, have a good day.